Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I am visible as well as equally audible? Then we would start right away. Yeah. Hi and welcome to Geeks. Okay, I'm fairly audible. So we would just wait for 1 or 2 minutes, then we would start right away. Let me turn on my yeah. So we would just wait for 1 minute. Okay. So we have successfully waited for the next 1 minute. So we would start right away. Vekanta, Shri Harsha, Shripash, Aditya More. Thanks a lot. Okay. So let's start with the today's session. Okay. Just a sec. Let me just connect my pen tab. Yeah. It's done. Okay. So today we would be discussing yesterday's problem of the day, that is mirror tree. This problem is an easy problem, but this problem appeared in 17 companies. Okay, this is a tree problem, not 17, 18 actually. Okay, so this has a success percentage of 63%. This is the easy level problem. Now let us understand the problem statement. We are given a binary tree. Now what is a binary tree? A binary tree is a tree which can have at most 2 children. Okay, so max 2 child. Fair enough. We need to convert to it mirror. Suppose there is a mirror kept at this position. Okay, so this would be this would come here, this would come here, this would come here, and this would come here. So it's just like this is a 7 written and we have a mirror in between. Then what is the thing that is? We have just like this thing. Okay, this thing, just the mirror image of it, and we need to find the mirror tree. Okay, so basically we need to just find the mirror tree. Now before finding the mirror tree, before looking at this example, let us first look at this example. Okay, so in this example, I would just color the left child with yellow color and the right child with green color, and the root would remain colored as red. Now let us just mark a mirror at this position. Fair enough. Now what we would do is we would just try to draw the same thing. So after the mirror thing, the main structure remains same. As this is a triangle, suppose we have a triangle like this. Okay, so the other triangle on its mirror image would also be like this only. So let us first this one. Okay, so the structure would remain same. Okay, now what we would do is we would first see where the root is going. The root this side remains here and the root this side also remains here. So we would just color this. So as I'm doing it, it seems very lame, but it would develop you a logic. Okay, so what I'm basically trying to do is I'm basically trying to inculcate in you the habit of doing the dry run or just enhancing your structural way of thinking. So just what we can do is this yellow was this side, so it would just move on that side. See this side, move on that side. This would come this side now. Okay, and this green side would just move to this position. So green side would move to this position. Fair enough, looks good, but there is the observation here. What is the observation, Siddharth? I would explain you. This was the root, this was the left child, this was the right child. So as you can see, the root remained at the same position, but the left and the right child got swapped with each other. Okay, now that you have seen this, let's again say this one. Let me remove the annotations so that you would understand it better, and let me draw a mirror in between so that it would be more realistic. Fair enough. Now you would see that this one came to this 3 came to this, and this 2 came to this. We can do the same thing, and this 5 came to this, and this 4 came to this. So we can see that we are just swapping the left and right child. But the thing is that we need to start swapping from the bottom. Why from the bottom? Because if you just swap the first two, sir, in the end also do explain dry run with code. I won't explain in the end what I would do it. I would code live itself. I won't show you the code which is already written. I would code live with explanation. At the end, I would do the dry run also. You don't need to bother about that. It's just that let me know what you need. Because if I don't know what you need, it might be the case that I don't need it, and I would think that you also don't need it. So let me know. Fair enough. Now let's move. So we can see that we need to swap the left child with the right child. Okay, fair enough. But there is the observation here. So swapping the left child and right child, we have two options. Either start from the root, or either start from the leaf node. Okay, the swapping thing. So if you just start swapping from the root node, you would see that we won't be able to keep a track of the lower values. Okay, suppose I just swapped 3 with 2. Suppose I start swapping this value. So this side value. So just let me remove all this. And I would start swapping this tree. Okay, just start swapping this tree as we have written. So what we can do is, we would just write this one. We would swap this. So 2 would come this side and 3 would come this side. So 2 came this side. And see, we have already kind of disrupted this structure, because we would know how which is having a left child and a right child. So what we need to do is, we need to first go inside this tree, reach to the leaf node, and then start swapping. Okay, this was the basic idea. Okay, fair enough, this was the basic idea. Now let me just try to do the output more, because for beginners it might be the case that this output would kind of seem a bit difficult. What are we doing here? It is told that the original trees in order, just suppose this is the tree, so this tree, after the reflection thing, mirror thing, this would be like this only 10, and this 30 would come here, so 30 would come here, this 20 would go this side, and this 60 would come here, and this 40 would go this side. This tree I'm talking about. Okay, now the next thing that I want to discuss with you is, we need to write the in order. Okay, the in order of this is 3, 30, 10, 60, 30, 10, and then again 60. Why so? Because we are showing you the in order output, in order traversal output. So in order, we first go to left child, we then go to root, and then the right child. You just need to remember this small thing which is mentioned at the top. Okay, fair enough. Now we would extend this idea. So what we would do is, we would take help of recursion. Okay, first, what I told, first we need to go inside this whole thing. So we would do what? We would first go inside. So let me start typing the code. That would be more beneficial, because explaining you the pseudo code, then again typing it would be a long process, and that would just take a lot of time. So let me just start typing the code. Okay, so let me just open the editor. It's, yeah, fair enough. So what we would do is, we don't need a wrapper function, we do it here only, because we don't need to return something, and the traversal thing would also not return something. So we would just go inside it, I told. So what we would do is, we would mirror mirror, then node, we would go to the left child, and then mirror, we would go to the node dash right child. Okay, now this would just make it go inside. But how far we wanna go? So this is going what? This is just, suppose we are at this tree, so we are just going at the left child, visiting the left child, then we are again visiting the right child. This is what we are doing. But we want a kind of base condition to remove this recursion, to stop this recursion. So what is the base condition? That we are at the leaf node. So leaf node's next left or right child would be null. So what we can do is, when the if node is equals to null, then what we would do is simply return. Okay, so we would just convey, first we are conveying what? That we would go deep inside this tree. Next, what we want is, we would just go deep, and this would go in endless time. So what we want, a kind of stopping thing. So what was the stopping thing? We just need to go till the leaf node. So leaf node's right child or left child would be null. Fair enough. Now we are just traversing. After this point, we would have the leaf nodes. So we know the leaf nodes. Now we just want the swapping of it. Fair enough. So we would just write swap. Okay. 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 Now let us see the output of it. Let me remove the annotations, and it should show me the output. We would see if we made any compilation errors or not. 213, yeah, 213. First let us submit, then we would do the dry run of this. Yeah, it's solved. Okay, now we would start with the dry run of this. Let me copy this code, how it is coming. So add it to a new page. We would just add it to the new page, and we would do the left and right swapping of this. Okay, let us do of this only. This seems a quite bit complicated, and this would remove all your errors. Okay, so let's start with the dry run. So what we are telling is, first we would draw a recursion tree. First, this mirror has this root node that is 10. So I would just write, instead of mirror, I would write m, and we would pass on 10 value. Okay, this is not null, so this won't be the case. This won't be doing the return part. So we are going on the left and we are going on the right. So what we are going is mirror dot left. So mirror dot left was 20. So now m dot 20. Okay, then we would visit the right child, but after this is complete. So now 20's left child again. 20's left child is 40. So again we would visit it. 40's left child is null. So at this point we would just start unfolding it. Okay, we were going deep inside. Now we would just go back. Okay, so this was done, m dot 40. Now this was the other. So left is done. Now we want to go to the right part. So this was m dot 60. So 60's next is also null. So these two are complete. I would mark the completed one like this. So as the left and right are visited, we would now come to this condition. Okay, that is, we would swap 40 and 60. Okay, so now this is swapped, so 60 would come at this position. Just let me draw a tree very small. 60 would come at this position and 40 would come at this position, and 20 remains the same. Now, as this is complete, tens, left tree is complete, we would just go to the right subtree. Okay, then we would come to m dot 30. M dot 30's left child is null as well as right child is null. So this is also complete. So we would just mark this is complete and this is also complete. Now we would just do the swapping of this, because if these two are complete, then we would come at this position. So 20 and 30 would now be swapped. So 30 would come at this position and 20 would come at this position, and the structure would remain the same. Now as these two are visited, this node's work is done, because we are not swapping the root itself. See, the root itself is not doing anything, so the root would remain same, that is 10 here. So we can see how this code is working. So whenever you find a recursive, suppose you are in the stage where you are learning recursion, then the first thing that you should do is, if you are not able to solve, then after looking at the solution, recursive codes looks very easy, but to have a deep understanding and to be able to solve for the next time, you should always try to do the dry run or draw the recursion tree, whatever helps you. Okay, fair enough. Now I would wait for the next 1 minute to see if we have any doubts or not. If you have understood, and if you are in the watching the stream, just let me know, yeah, it's understood, or you can provide me feedback, what parts should I improve upon. Okay, so I would be starting the timer now. I would wait for 1 minute 20 seconds. Okay, let's wait for 1 minute 20 seconds now. I guess the dry run final image is not correct mirror image. Let me just see. 30 and 20. Okay, I am extremely sorry about that. I'm extremely sorry. I just attached this tree wrongly. Yeah, sorry about that. It should come here. Sorry about that. I told the connections would remain same. We are not swapping the connections or breaking the connections. The connection would remain same. Just this thing. Yeah, I'm extremely sorry about that. Thanks a lot. Yeah. Actually, I drew this side and I just swapped the parent. So it was a kind of mistake. I didn't notice it. I'm extremely sorry from my side. So as I made a mistake, I would again wait for the next 1 minute. And thanks a lot, Srijan, for this one. Okay. Okay, so that's it from my side. If you still have any queries or if you have any feedback for me, let me know in the comments and I would try to resolve them. Okay, that's all. Thank you and have a nice day.